we are doing 214 homework problem number 5. So we have can we use the model relationship between the earthquake's magnitude and the maximum ground displacement in microns, or define the values of A and B. So we are given 21, 5.2, and 180, 6.1. Okay, so did you set up a couple of equations? And so 5.2 equals A plus B log 21, and 6.1 equals A plus B log 180. Is that okay with everyone? Okay, so we got a little system of equations, and we're going to solve that system. So I think I will use substitution. So I'll get A by itself. You don't have to do this, but that's how I'm going to, actually, could I eliminate? Maybe I'll just eliminate. I like that better anyway. So I'm just going to eliminate. So I'm going to multiply this one by a negative. So I'll have 0.9, the A's are gone, equals B log 180 minus B log 21. So I took this equation minus this one. Keep an eye on my arithmetic. Did everything look okay? All right. Now, what can I do here? Factor out of B. So log 180 minus log 21. Now, you can combine those if you want, but I'm going to have to go to my calculator anyway, so I think I'll just leave it that way. However, if I do leave it that way, I have to remember when I type it in that that whole thing is in the bottom. Okay, so let's see what I come up with. 0.9 divided by log 180 minus log 21. I got 0.965. Does that match anyone? I have the key. Yeah. So then I'll go back and put that in for my B and solve for my A. So A equals 5.2 minus B log 21. Would you agree with that, Celeste? That's what A equals. So I'm just going to take 5.2 minus this answer is still in my calculator. So answer times log 21. And for A, I got 3.925. So then I know my equation is M equals 3.925 plus 0.965 log x. Does that look okay for an equation? Okay. Now, find the maximum ground displacement for a 9.5 magnitude earthquake. So remember, 9.5 magnitude, that is my M. So I'm going to put 9.5 equals all this. So would you agree that I'm going to subtract and divide? Okay, so I'm going to have 9.5 minus 3.925. And I'm going to divide that by 0.965. So I have something like 57772 equals log x. Now what? Charlie? Exactly. If you can't solve it in its logarithm form, change it to its exponent form. So 10 raised to my answer, and I got 598,690. I don't even know what the unit on that is. I got a different answer on the key because, so I may have marked that one wrong. If you got that, you're okay. You're okay. I did it on my key without rounding anything off. So I used the A and the B that I actually got, and not the rounded off ones. And so that's how I got my answer here. If you did this, it's okay. If you got that, I think a couple people got that. I remember that number or something like that. And the unit on that would be what? Microns? Is that okay? Okay, Charlie? Which one? D?
Yeah.
As in dog?
Yes.
Do I need to do all the rest of the stuff? How many years does the model predict? So I have the model, all right, I don't need to find it. I have the model. So the model is this. Oh, by the way, some of you did a magnificent job with your explanations for like number 3. I'm gonna come back to this in a minute, Charlie, but number 3, the height of the tree. One of the questions was, why does a logarithmic model make sense? What happens when you go out in your backyard and you plant a tree? In the first few years, what happens to that tree? It keeps growing, right? But what happens the older the tree gets? It's still alive and it's still growing, but what happens? The growing levels off. So a logarithmic curve is perfect for that because it shows that initial growth and then it shows the leveling off. What about the child learning the words? Isn't that the same thing? I mean, think about when you were 2 years old, how many new words you were learning, and how many new words are you learning right now? Not nearly as many, right? And how many am I learning? Not very many. So in the beginning, learning, oh, lots. But then the older you get, the fewer you learn. Okay, anyway, some of you did a magnificent job with that. All right, so what am I doing here? The amount it'll take to learn 15,000 words. Okay, so I got it on my, okay, so this is the words in thousands. And T is months. So those are my variables. So the question says, how many years does the model predict it will take to learn 15,000 words? So aren't I gonna put 15 right here, not 15,000, but 15. And now we'll solve that. So I'll add 13 and divide by 10. So if I add 13, I get 28, divide by 10, so 2.8 equals log T. Does that make sense to you, Charlie?
Oh, I just forgot to put the 10 out front. That's where I went wrong.
Oh, of the equation?
Yeah.
Okay.
Yeah.
So then it's back to where we were a minute ago, so we're gonna take 10 to the 2.8. And I got 630, but remember that's 630 what? Months. So I have to divide that by 12. So I got 52.58, basically, 580. All right. Anything else from that? All right, let's get our review out then. We finished the single page review, but we still have plenty of review here. We did that page was called extra review. We finished that. And is the only thing we did on the other review, that problem 17? All right, then let's start with the paper called Review Topics 2.7. That's all cut and pasted in my handwriting. Okay, let's just start there. And how do you want to do this? You want to have some, the period is going to end at 25, so we have 20 minutes. We can just start at the beginning and crank through. I'm happy to do that. Or would you rather work with yourselves for a few minutes and then take questions? What is most productive for you? You won't hurt my feelings either way. I don't care. I'm happy to stand up here and blab.
I would rather you do.
Okay, Will wants me to blab. So I'll blab for Will, and then I will stop blabbing after a bit. Give you a few minutes to struggle through some stuff on your own if you want. Thinking about invertible functions, identify which of the 4 listed functions is the odd one out. Now what that means is, I'm not sure which one it is, but 3 of them are the same in terms of having an inverse or not having an inverse. And then one of them doesn't match those. So either 3 of them have an inverse and one doesn't, or one of them has an inverse and the other 3 don't. So I don't know, let's look at it and see. Any ideas? What do we know about inverses? Functions that have inverses. They're 1-to-1. And what does that mean? They pass both the vertical line test and the horizontal line test. 1-to-1 means that there are no repeated x's and there are no repeated y's. So what does negative x to the 5th look like? It looks exactly like negative x to the 3rd. What does negative x to the 3rd look like? This right here. Does that function, that is negative x to the 5th. As long as you don't add stuff to it, like plus x to the 4th minus 3x cubed or something, that's what it looks like. Does it have an inverse? Yes. Because it passes the horizontal line test. There are no repeated y's. Every single point on this has the same y. So when I do the inverse, they have an individual x. They have different x. All right, what does e to the x look like? Right there? Does that have an inverse? Yeah, it's called ln. The natural logarithm is the inverse of that. So, yep, that one has an inverse. Both of these have inverses. What does x to the 4th look like? It looks just like x squared. There's no bounciness or waviness unless you put in some other things. If it's straight x to the 4th, x to the 6th, x to the 8th, it looks just like that. Does that have an inverse? No. Not an inverse that's a function anyway, right? Because, see this point right here? This is x to the 4th. This is the point 2 comma 16. And this is the point negative 2 comma 16. So what happens when you do the inverse? you have 16, -2, and 16, 2. Are you allowed to have that? No. So that's the odd one out. There's no inverse for that guy. What does 1 over x look like? The reciprocal function. Does that have an inverse? Yeah, and actually it's itself. Its inverse is itself. So, x to the 4th is the odd one out. Okay, number 2. We have two functions, p and then g, the picture of g there. Find 2 times p of g of 0. Oh my. Okay, so what do you think we should do first? Find g of 0. So let's look at the picture. Can we find g of 0 on this picture? G of 0 is -4. Did I count right? So 2 times p of -4. Well, what's p of -4? You get -7. So 2 times that would be -14 for my answer. Without finding the inverse, okay? So we're not gonna find the inverse, but we're gonna answer all these questions about the inverse. So here's my function. Let's answer these questions about the function. So what's the domain of g, of this function? What is the domain? Everything but 4. So I'll write that like a mathematician, but you're right. It's everything but 4. So everything coming up to 4 and everything after 4. That's my domain of the original. What's the range of the original? Patrick?
Everything but 0.
Everything but 0. Now, ranges are hard. I get it. I don't like ranges either. But I want you to think about, this is a fraction. X can be anything except 4, so it can be positive numbers, negative numbers, big numbers, little numbers, it can be everything. But no matter what, that fraction will never equal 0. Because the only way that fraction can equal 0 is if that is 0, and it can't be 0 because it's 1. So, now I'm doing the vertical asymptote for g and the horizontal asymptote for g. All right, vertical asymptote. Well, if x can be everything except 4, isn't my vertical asymptote at 4? And if my range can be everything but 0, my horizontal asymptote is at 0, and that makes sense. 1 over, that makes perfectly good sense. So, answer the questions about the inverse now. Easy. What's going to happen? This is going to be the domain of the inverse. This is going to be the range of the inverse. What was a vertical asymptote will now become a horizontal asymptote, and vice versa. what do we do? What are our steps that we go through if we are going to find an inverse? Switch them. And then get y by itself. So I've done the algebra now. Now I gotta make sure it meshes with the whole problem. But are you okay with that? All right. Now here's the deal. It says x has to be less than or equal to 0. So in my original problem, x is less than or equal to 0. Now, how am I going to use that fact when I do my inverse now?
Delete y is less than 0?
Exactly. So that means when I have an option, which I always do when I square root, I will choose the negative option because I had the x's were negative in the original, so the y's are going to be negative in the inverse. Does that make sense to everybody? And the reason that we have that is, here's the original function. When you find its inverse, it looks like this, okay? This is not a function. So when we say, okay, we only want the negative part of the original parabola, that means I only want the negative part of the inverse parabola. All right, number 5, last one. Consider, last one for today. Consider f defined as this, x cubed plus 2. Two statements are true, one is a lie. Which one's the lie, and how could you make it true? Do you know what x cubed plus 2 looks like? Like that, right? But instead of going through the origin, it's going to go through 2, so it's going to look like this. That's x cubed plus 2. Number 1 says it's invertible and increasing. Invertible means it has a function, has an inverse that's a function. Is that 1-to-1? Yep. Is it increasing? Yep, that's a true statement. F has a y-intercept at 2, which indicates that f inverse of 2 is 0. I think that's true too. All right, I hope C is false. The inverse would look like this. Okay, so here's our original. I switch my variables. Oh wait, I can tell already that's false. Because isn't solving this gonna involve a cube root? Yeah, so that C is false. What does the inverse look like? The cube root of x minus 2. That's what the inverse would look like. Okay? All right. Well, we'll stop there. You guys got a few minutes, or what did I say? Yeah, you got a few minutes to work a little bit on your own. For those of you that like to do that.